Hello friends, so today we are going to discuss about cyclic redundancy check. So this is a mechanism used for error detection rather than correction. It is used for detection, and it was first developed in 1961. Was developed in 1961 by a scientist called W. Wesley Peterson. So it was developed by W. Wesley Peterson in 1961. So though it was developed in 61, it was not until 75 that it was used in Ethernet. So Ethernet, we all know, it is basic LAN connectivity. So in Ethernet it was implemented in 1975. Okay. So this is based on the concept of the division of binary numbers. We all know the basic division of binary numbers takes place using the logic table of XOR operation. So that is how it works. Now we'll be explaining how the cyclic redundancy check is implemented. Let's say we have to transmit a data. Let's take a simple data 100 100. So if this is the data to be transmitted, what we'll be doing is uh, on the sender side and on the receiver side. Now this is the data to be transmitted, right? Uh, on the sender side and receiver side, we'll be taking a divisor in common. Okay, we'll be taking a divisor in common. So let's say, for example, in our example, let it be 1101. So this will be common on both the sides. So what we'll be doing here is we'll be taking our data, we'll be dividing it using the divisor on the sender side, and we'll be sending some manipulative data along with this main data. On the receiver side, uh, the data altogether is again divided using the same divisor and verified for the result. Okay, so that is the way it works. So we'll be implementing an example here in front of you today. So there are certain norms that we must be knowing before implementing this. So what we'll be doing is we'll be taking this data, let's say 100 100, and based upon the divisor, let's say this is the divisor. Now here 4 bits are there. We'll be taking 1 bit less than the divisor, that is 3 bits. We'll be taking 3 bits of that manipulative data as zeros and adding it to the our original data. Okay, so why we took here 3 zeros is because our divisor was having 4 bits. If our divisor was having 5 bits, we'll be taking 400. Okay, so it will be always 1 less than the divisor number of bits of the divisor. Okay, and it will be always 0, we can't take 1. Okay, so this is the manipulated data that we have added along with our main data. Now what we'll be doing is we'll be dividing it. Okay, so for instance, let us say this is the data 100 100. This is the manipulated data, and here the divisor used is 1101. Now for those who are not aware of the XOR operation, let me tell them. XOR operation is a logic operation where two inputs are there, input 1 and input 2, and the output will be provided based on whether the inputs are same or not. Let's say if we have 1 1 or 0 0, if the same input are there, then the collective output will be always 0. If one input is 1 and other 0, or vice versa, it will be having 1 as the output. Okay, so this is the basic XOR operation. So this is the XOR operation, so that will be implementing here. Now what we'll be doing is we'll be just dividing the given data, 1101. Okay, now here the two bits will be considered as two inputs here. Okay, so here the same bits are there, so we'll be considering the output as 0. Again the same bits, so 0. Here comes the different bits, so one is 0 and other is 1, so the output will be 1. So this is again the same bits, so we won't be considering it because it is 0 as such. Now we'll be taking down this bit as the usual division case. So again 1101. So here we won't be considering because it is 0, it is 1 0 1, right? Now we'll be taking this bit as 0. Now again 1101. This we won't be considering because it is already same, so it will be 0. Now here it is 1, here it is 1, here it is 1. Now we'll be taking this bit as 0, right? So again we'll be considering it as 1101. Now here both bits are same, so we won't be considering. Here it is different, here it is different. Now again 0. Now again, right? So here we will be considering it as 1 1101. Here it is 0, here it is 0, here it is 0, here it is 1, right? So this is the final reminder that we are getting. So let me tell you that this quotient is not used anywhere, so we are not bothered about that. What we'll be using here is this reminder. Now this out of this reminder, though we have more than 3 bits, what we'll be doing is, as we had considered here only 3 bits, we'll be replacing these 3 bits using this value. So the resultant will be 100 100 001. So this is the data or the final data that will be transmitting to the receiver. Okay, final data. Now on the receiver side, again we'll be dividing this content. Okay, so this was on the sender side. Now this is on the receiver side. In the receiver side, what we'll be doing is we'll be considering this uh, data that our final data which is to be transmitted, and then we'll be taking the same devices that we had decided by default. Now we'll be dividing it. Okay, 1101. So same 0, same 0, different 1. Now we'll be taking this bit 1101, same 0, different 1, same 0, different 1. Again 1101, same 0, different 1, different 1, different 1, and we'll be taking 0 1101 0011. We will be taking 01 because we require 4 bits, so we pull down this board together. So once 1101. Now here we don't have any remainder, that is all be 0, everything will be 0. Now once the full output is, sorry, I hope now it is visible. Now when the output is altogether 0, so what we'll be doing is we consider that there is no error, there is 0 error. In case if we didn't get zeros here, now you will see everything is same. So when we as per the concept of XOR, if two inputs are same, the resultant is 0. So in this case every bit will be 0 out the output, right? So when all the bits here that we get is 0, we consider that there is no error in the transmitted data, that is this data transmitted is very accurate. And as we know, the last 3 bits are the manipulative bits. We just remove it out and we just consider the main data that we have. So this was the simple concept of cyclic redundancy check. I hope the concept is clear. See you in the next class. Thank you.